This video clearly debunks the debunker who claims that his using a camera to estimate its angular size has proven the flat earth false. This is complete garbage, and I'm going to demonstrate why. And I'm going to demonstrate how Mr. Dazza, the cameraman, has fallen far short of proving that we do not live on a flat earth. In fact, we do live on a flat earth, and in fact, the size of the sun from the horizon to 11 degrees does change in its size. I would like to quote here, an object's angular size is approximately proportional to the object's physical side over its distance from the observer. Now, Mr. Dazza claims that you have to zoom in with a certain lens to see the disk of the sun, and that glare or haze or atmospheric conditions would distort that. And that is true to a point. However, that glare will stay proportional to the object. And we're going to show that what he says is not true. And he has omitted data that would prove him completely wrong. Okay, I'm using footage here from P-Brain's video that's perfect for showing that Dazza is wrong. Okay, let's pull apart Mr. Dazza, the cameraman's expose here on trying to prove the flat earth false. First of all, he has, on July 12th, 7:44 a.m., he takes a picture of the sun with a zoom lens at an 11-degree angle. Then at 10:52 a.m., he takes another picture of the sun, 47 degrees altitude angle. Then at 1:30, he takes another picture of the sun at a 66-degree angle, and then concludes that this proves that the flat earth is false. And this is garbage, and I'm going to explain why. But let's just let him talk about this. I've included only the 744 image and the 130 image because the middle image is the 1052 image is negligible. We just want to deal with the 744 and the 130, and I'm going to explain to you how this is does not prove that the flat earth is false.
Right in on the sun and let the camera adjust so it's properly focused. Okay, it's just gone 1:30 p.m. on Friday the 12th of February 2016. And as before, let's zoom right in on the sun and let the camera adjust, and then I'll set the manual focus. Get it nice and steady. It's 11 degrees at 7:44 a.m. 47 degrees at 10:52 a.m. and 66 degrees at 1:30 p.m. when the sun was at its highest point in the sky. Now, how does this compare to what we should see? Let's take a look. Okay, here is the angular size calculator that was provided by Mick West from Debunk, and as we can see, we've got our sun set at 3,000 miles altitude. The diameter of our sun is 32 miles in diameter, and this is our viewing angle here. Now this represents the angular size of the sun. Now I should point out that the angular size of the sun is shown here is not to the same scale as the altitude and diameter of the sun, but as the angular size of the sun changes, that change is to scale with our angle and viewing distance. Okay, so at the moment I've got this set to 11.5 degrees, and this is the angular size by comparison of what the sun should look like at that distance. When I drag this back so that we're looking at 47 degrees, you can see that the sun up the top there is larger. So 47, let's make that about 47.5. Okay, so that's the angular size of the sun compared to what it was before at 47 degrees. And at 66 degrees, which was when the sun was at its highest point, that would be the angular size of the sun compared to where we started off. Point being, obviously, if I drag that down there and compare that to our height, it is not 3,000 miles in diameter. We're comparing the change in angular size. So that's from 66 degrees down to, what did I say, 11.5 degrees. So that's a change in our angular size of the sun. This is what we should expect to see if the Earth is indeed flat.
Okay, what I'm going to do here is break down exactly what Mr. Dazza has done and show how it's incorrect and not accurate and not true to reality. As you can see, there are two diagrams here, and these are taken from P-Brain's video footage of the sun rising. And you will see that I've put a protractor on the bottom image, and you can see as it moves up 11 degrees to the sun, and the upper clip shows 66 degrees. And you can see that on the upper image that the sun from 11 degrees to 66 degrees, and it's the 66 degrees, you can't see the sun actually going there, but it stays the same size all the way from 11 degrees to 66.5 degrees, we'll say. So what we are showing here is that if you look at the horizon on the bottom view where that small dot is, that is actually where you would measure the angle of the sun, not at 11 degrees at 7:44 a.m. You would measure it from the horizon to that point, because that is where it changes. That is where it all joins together. So what I would call the point of convergence, where 3,000 miles away, 3,000 miles high converges, and the sun would be at the same size, which is correct in that sense. But when you take and consider all of the facts, you can see that the sun does get bigger. Absolutely. So Mr. D has failed to debunk the flat Earth, because we have shown that the sun does, from the horizon to 11 degrees, change in size. And you'll notice that he starts at 11 degrees. Very interesting. I'm sure he knew what he was doing. Also, this image here of the sun being 93 million miles away, and what it would look like if that was the case, you can see that the sun would cover the whole horizon. This is not the case. The bottom view is the case, and this is how it looks. We will now end with a video that proves absolutely, and also takes the advice of Mr. Dazza, where he says, try it for yourself. Well, someone did, and came up with completely different results. So either he deliberately lied and changed things to make it look like the sun never changes in size as it comes from the horizon to setting, or he just doesn't understand what he's doing.
I was out in the afternoon and it was a beautiful day, and the day was the 25th of February 2016, and the previous day I practiced taking a photograph of the sun, only viewing the sun through the LCD screen, so therefore not damaging my eyes or retina, which must be avoided at all times. But I managed to zoom up to the sun at midday at 12 o'clock and at times 40 magnification. The sun fit exactly into the frame. And I repeated this experiment later on that afternoon, exactly 3 hours later. My location had changed from Barnet to Hackney, but in terms of the solar system, this is a very minute adjustment to the experiment. So the next shot you will see is myself zooming up to the sun, viewing the sun only through the LCD screen. At first it was hard to find the sun through the clouds, but as I got my and it was also quite difficult to get the magnification spot on 40 times magnification, but eventually I did, and I located the sun, and I could see that the sun was further away. It was actually smaller. It had decreased in size. It didn't fit the whole frame, which I thought was very peculiar, because with the sun is meant to be 93 million miles away. Anyway, at 40 times magnification, the sun was then only 3 hours later. It was a lot smaller. So I zoomed up to times 50, and then I tried to fill the frame with the sun, and this would only happen at magnification times 75. Spot on at 75. So after 3 hours in the afternoon, the sun was roughly 35 times smaller in camera magnification terms. Thank you.